Dear all, here we are going to discuss about the solar cell IV characteristics. In this setup, we require solar cell, halogen lamp, voltmeter to measure the voltage, ammeter to measure the current value, variable dimmer to increase or decrease the light intensity which is fall on the solar cell, and the load resistance with varying the voltage load resistance we can get the current and the voltage rate. This is the lamp and the solar cell. The cell can be placed at different distances. As we know that the efficiency depends upon the distance between the cell and the light also. By varying the distance, the efficiency is also changes. That's what in this experiment we fix a particular distance between the lamp and the solar cell. These are the cables. Some are the dual cables which is having some hole, that means that we can connect the two wires and this is the circuit symbol of the solar cell. So when you observe the circuit symbol, so this is the cell, that is light fall on the cell is parallel with the voltmeter and the ammeter is connected in series and load resistance, and these are the this is the table what we need to measure in this particular experiment. So the first column is the serial number, second one is the distance between the cell and the lamp, and third one is the voltage and current and the power. This is the model graph related to the IV characteristics of the solar cell. So here you just observe the things like open circuit voltage and short circuit current. When you see the circuit diagram, the connection point of view, see this is the light and it is the cell, it is a voltmeter, ammeter and load. Just you can observe here the light exposed on the solar cell, and the cell positive is connected to the voltmeter positive, that means voltmeter and cell are both are parallel each other, and ammeter is connected in series. So here just you observe the solar cell positive is connected to the voltmeter positive, solar cell negative is connected with the ammeter negative, voltmeter positive is connected to the ammeter positive, ammeter negative is connected to the load, and load is connected to the either voltmeter negative or the solar cell negative. Just see, this is the circuit diagram. By using this circuit diagram, we are going to connect the terminals in the solar cell to calculate the IV characteristics of a given solar cell. So here, this is the voltmeter, this is the ammeter, and it is the load, external load. We can vary the load resistance in between 0 to 1000 volts. This is the on and off button, and is a variable dimmer, or else we can use it as direct to the power supply. By using the variable dimmer, we can increase or decrease the light intensity. See, here also we can vary the distance between the light to the solar cell. I just given the distance is 5 centimeter between the solar cell and the light distance. I placed at 5 centimeters. If you on this, so the light is exposed on the solar cell. Now the connection point of view, based on the circuit diagram, we just connect the first voltmeter ammeter point of view. Voltmeter positive is connected with the ammeter positive, and ammeter negative is connected to the load. Load doesn't have any positive negative. That's what ammeter negative is connected to the load, and then load other terminal is connected either voltmeter negative or solar cell point of view. So this is the voltmeter and ammeter connection. Now the solar cell is parallelly connected with the voltmeter. So the positive is connected to the positive and negative is connected to the negative. Right? The connections are over. Now we need to calculate the IV characteristics of solar cell. Before this, we need to check the circuit is in the open bias circuit. In case of open bias, what is the meaning of open bias? If the circuit is breaks, that is called as, when the load is removed in the connections, that is called as open circuit. Just a minute. Now I want to calculate the initially open bias voltage. Open bias voltage is nothing but this, when the circuit breaks, then the corresponding voltage in the circuit is taken as the open bias voltage. To get the open bias voltage, I just removed the one of the terminal of the load, then it discontinued from the circuit, then the corresponding voltage at that moment is taken as the open bias voltage. So for example, when you take in here it is 0.439, that should be considered as the open bias voltage. At that moment the corresponding current value is 0. So if you want to get the short circuit current, so we need to take the two terminals and we just connect the positive negative terminals, then this connection is taken as a short circuit connection. In case of short circuit current, the current is maximum and the voltage is minimum. The corresponding voltage in the ammeter is taken as the short circuit current value. Now it is 9.02 milliamps is taken as the short circuit current. We should note, in the process of calculating the IV characteristics of solar cell, just we will give the resistance. We will increase the resistance and note down the corresponding voltage as well as current readings. So for example, here the current value is 8.75 milliamps and the corresponding voltage is 0.137. It should be taken as the reading 1, and then just increase the resistance value. The corresponding voltage is around 0.181 is taken as the second point reading, and 8.42 is the second point current, and the third one 0.325 and 5.32 is the corresponding voltage and current for a given resistance value. I keep on increasing the resistance value. Now it is 0.354 and 4.30. 0.382, 3.02, 0.395, 2.37. Just note down all the values of the voltage and the current by changing the resistance value. 0.403 is the voltage and 1.96 milliamps is the current value. 0.412, 1.37. 0.416, 1.12. 0.426, 0.65. 0.423, 0.56. 0.426, 0.43. 0.427, 0.42. These are the points, these are the values for different resistance values. Just note down both the values of voltage as well as current in the. By using these values, just draw the graph by taking all these values. Just take a graph by taking voltage on x-axis parameter and current on y-axis parameter. So by using that curve, so we can calculate the IV characteristics of solar cell.